Hello, amazing sixth graders. Miss Cowie and I hope you guys had a very nice, relaxing Memorial Day weekend, and now we're ready to get back into our lessons. Today's lesson is on global warming, and the target for you today is I can explain what global warming is and the causes of it. So let's get started. Let's get started with that first part of the target. What is global warming? So we're going to use some definitions here to explain it. Basically, let's define global warming. When people say global warming, when scientists talk about global warming, that refers to an increase in the Earth's average temperature over a long period of time. This basically means is the Earth getting hotter, global warming, or getting colder, global cooling. A lot of people get global warming and climate change mixed up. They interchange them when they shouldn't. The definition of climate change is significant changes in the climate lasting for extended periods of time. In other words, climate change includes major changes in temperature, precipitation, wind patterns, and other things that occur over decades or longer. Global warming only refers to the increase in the Earth's average temperature over a long period of time. So in your target where it says, I can explain what global warming is, well, global warming is the increase in the Earth's average temperature over a long period of time. Global warming causes the climate change. This increase in the Earth's temperature causes changes to the climate. Today we're only going to focus on global warming. Next week we'll focus more on climate change. All right, so the claim, global warming. The Earth's average temperature is increasing. That's what global warming claims. But as scientists, we need to have evidence. So what evidence do we have to support the claim that the Earth's temperatures are rising? We actually have a lot. Let's look at some of that evidence. Here is a graph from NASA that shows the difference in temperature from 1880 to 2019. This is the average, the difference in the long-term average of the temperature. And we notice here that from 1880 to 1930, the average temperature on the Earth was colder than normal. Then we get a period of warm, some cold, period of warm. And starting about 1980, what do you notice here? That the average Earth temperature increases. Global warming. Let's look at some more data. This is another graph from NASA that shows the same thing. It shows from 1860 to 2000. I think it goes to 2009. What do you notice about the temperatures? What is happening with this red line? It's increasing, right? So global temperatures on average are increasing. Let's look at a few more. Here is a graphic that shows where and how the temperatures have been increasing since 1880. The blue represents cold, and the yellow and the red represent warmer than average. So here we are in about 1970, and then starting in the 1980s, we notice that the entire world almost, on average, is hotter than normal. Let's look at another one. This graph shows each country and their temperature change away from normal between 1880 and 2017. The blue represents colder and the red represents warmer. And what do you notice about as we get into the 2000s? Every single country reports a warmer than average temperature. So here is the difference from average temperatures for 2019. And you notice some places in the world are a little colder than normal. But in general, most of the world is warmer than normal. And actually 2019 was the second warmest year on record since 1880. On average, it was about 2 degrees warmer than pre-industrial time. And this again comes from the National Oceanic and Atmospheric Agency. That's our weather agency in the United States. So I just showed you a whole bunch of data that shows the temperature's rising. Well, what are some more facts that support this claim that the Earth's temperature is rising? Like we said, in 2019, the average global temperature was 1.7 degrees above the 20th century average of 57 degrees, making it the second warmest year on record. The 5 warmest years between this period of 1880 and 2019 have all occurred since 2015. 9 of the 10 warmest years have all occurred since 2005. And finally, the global annual temperature has increased at an average rate of 0.1 degrees Fahrenheit per decade since 1880. And then starting in 1981, it's been increasing at twice that rate, about 0.3 degrees Fahrenheit. And these little temperatures may not seem like a huge deal to you, 1 degree Fahrenheit, 0.3 degrees Fahrenheit. But when we talk about climate change, we'll explain why that is such a big deal. So, the claimed global warming, the Earth's average temperature is increasing. The evidence? Well, data collected since 1880 shows that the Earth's average temperature has risen over the past 140 years. But why? What is the reasoning for that? When you talk about global warming and climate change, there are some skeptics, people who don't believe it. And they'll say things like, throughout the Earth's history, temperatures have risen and fallen in a cycle, and therefore our current situation with our temperatures rising is natural, not something to be concerned about, and not caused by humans. And a lot of times they'll refer to this data graph that we have here. This is the average global temperature over the past almost million years, 800,000 years. And they're right. The skeptics are right when they say we've gone through periods of warming and cooling that seem to happen in a cycle. Because if you look at this graph, you can see there are periods of warming and cooling, warming, cooling, and so on, all the way up until present day. But we have to remember the greenhouse effect, the lesson that we had last week, and that these greenhouse gases trap heat in the atmosphere. So when skeptics use this graph, they often don't talk about what the greenhouse gases look like during that period. So let's look at how carbon dioxide has kind of risen and fallen over the past 800,000 years. When temperatures are high, what do we notice about carbon dioxide? They're high as well. When temperatures are low, carbon dioxide's low. Temperatures high, carbon dioxide high. Temperatures low, carbon dioxide low. Where I want us to focus is over here, the current carbon dioxide levels in modern day. And if we notice, these carbon dioxide levels are currently off the chart. They are higher, almost twice as high, but higher than they have been in the past 800,000 years. How do scientists know that carbon dioxide levels now are higher than what they were 800,000 years ago? Well, they use ice cores. And what they do is they dig way down into glaciers and they take samples of the ice. And in that ice, there's little air bubbles that are trapped. And those little air bubbles show us what the atmosphere was like at the time that glacier formed. So they're able to go back and look and say 800,000 years ago, how much carbon dioxide was in these air bubbles? And that's how they decide. So let's look at carbon dioxide. This right here shows us the carbon dioxide levels since 1979. This side over here tells us where they are, what their levels are in different places in the world. So on this side of the graph, it's showing us the southern hemisphere below the equator. And this side of the graph, it's showing us the northern hemisphere carbon dioxide levels. And then this graph right here is showing us the yearly trend of carbon dioxide in the atmosphere. And if we look since 1980, what do we notice is happening? Those carbon dioxide levels are spiking. You can also see over here the northern hemisphere seems to produce more carbon dioxide than the southern hemisphere. That's because China and North America, the two largest producers of carbon dioxide, are located in the northern hemisphere. So now we're in year 2009, 2010, and you notice this graph is starting to get steeper and steeper, and the carbon dioxide levels are going up and up and up. All the way to 2019. 2019 in January, there was 411 parts per million. That means for every million molecules in the atmosphere, 411 of them were carbon dioxide. Now what we're going to do is we're going to go back in time on this graph and look at carbon dioxide levels back in time. So this is back to the year 500. We're going to go even further back in time. Remember, modern days right here, carbon dioxide levels were lower. This is 60,000 years ago, 150,000 years ago, 200,000 years ago, and we'll keep going and going and going. So here we are going back 800,000 years ago. Carbon dioxide levels. This is when the temperatures were high. This is when the temperatures were low. And when we look at these carbon dioxide levels, we know that the higher the carbon dioxide, the higher the temperature. But look at current day levels, way up here. As of April, we are at 417 parts per million carbon dioxide in the atmosphere. This is higher than it has ever been in the past 800,000 years. So when skeptics look at that temperature graph and say that the temperature goes in a cycle, sometimes it's high and sometimes it's low, they're right, but they need to take into account the carbon dioxide levels. We are currently at the highest carbon dioxide levels in history. So what is that going to do to our temperatures? Carbon dioxide causes an increase in temperature, so we expect the temperatures to rise to highest level ever too. Carbon dioxide is not the only greenhouse gas. Let's look at some other greenhouse gases. Nitrous oxide is another greenhouse gas. A nitrous oxide molecule that's released into the atmosphere will stay in the atmosphere for 114 years on average before it's either destroyed through chemical processes or it's stored in what we call a sink, which we'll talk about later. But what do we notice about nitrous oxide levels over the past 20 years? They're rising. And nitrous oxide is actually much more dangerous to the atmosphere than carbon dioxide. One nitrous oxide molecule can trap almost 300 times as much heat as one molecule of carbon dioxide. So carbon dioxide's increasing, it's at an all-time high. Nitrous oxide is increasing, it's at an all-time high. And methane, another greenhouse gas, is again at an all-time high. Methane spends an average of 12 years in the atmosphere, and methane traps 28 times more heat than carbon dioxide. So all greenhouse gases are at an all-time high. So global warming, the claim is the Earth's average temperature is increasing. We know that to be true because of the evidence. The data shows us the Earth's average temperature has risen over the past 140 years. The reasoning, why does that happen? Well, greenhouse gases are at an all-time high in our atmosphere, trapping more heat than ever before in our atmosphere. This diagram or this animation over here is going to show you the global temperature changes since 1800 to the projected year of 2100. And the UN and the International Climate Change Agency predicts that global temperatures are on course to rise 5.4 to 9 degrees Fahrenheit in the 21st century, between 2000 and 2100. That's what this little graph shows us over here. All right, so that's it. Let's review our target. Your target was I can explain what global warming is and the causes. Well, global warming is the average increase in the global temperature. And what's causing that? An increase in greenhouse gases. So I just wanted to give you a brief overview of where we're going from now until the end of school. So our next lesson, which will be optional for some kids because of Memorial Day, is going to talk about what are some sources of greenhouse gases, both naturally and from humans. And then next week, we're going to talk about climate change. And that is basically what is the impact of global warming on the earth. And the last week of school, we'll talk about what you can do to help stop global warming and climate change. All right, I hope you guys enjoy the rest of your day, finish up this lesson, and we will talk to you again later in the week.